This video is going to show you the use of our new wafer map and yield monitor displays. You can see right here that the wafer map is operating, filling in. This shows our wafer map in operation here. Each one of these die locations has the software bin inside of it. And off to the side here we have the color code with the software bin, hardware bin, and the yield for that bin. If we select the bin summary here, we can see that as the wafer is filling in, the software bins that are being encountered are being added to this list here. So we have the software bin name, the type, good or bad, and the hardware bin number and the software bin number over here. We also have the hardware bin description or name if it is available, and then we have a count and the percentage. In this particular case, we're only testing single site, so when we click on our yield per site, we'll only see one box here. If we had, for example, 4 sites, and we'd see 4 boxes here showing the yield per each site. Clicking on yield trend shows that we are on the 8th wafer of this lot, and any one of these boxes here which shows the yield per wafer, if we click on that box, it brings up the wafer map from that particular wafer showing the bin results. From the bin summary tab, if we click on the software bin bar chart, we get a nice histogram showing the software bin distribution. We've reached the end of the lot here. This is the 10th wafer. The wafer map display also has a nice feature here where you can show the lot and wafer variables. These are all the application model variables that are collected while the wafers are running. So you can see right here wafer ID is W10, which was the 10th wafer, and it shows the cassette ID and the device path and name and any other information that's defined by parameters from the application model. In addition to collecting live data, we also have the ability to save the chart, including the wafer map and the bin chart that we showed you earlier. You can also export the bin summary to a CSV file and export the lot wafer variables to a CSV file. So those are nice for doing reports after you've collected all your data. In addition to the features that I've already shown you, the wafer map also rescales nicely. This is a VNC session, so you can see that it works very smoothly, and if we obscure the window and then bring it back up, it repaints correctly, which is not always true with a VNC session. The wafer map display also has some nice features here where you can control the font size and you can turn the software bin number on and off, and you can also select site. There's also a feature to do a wafer map overlay, which I won't demonstrate in this video. This is the new final test display. As you can see, this is 4 sites. Each of the site tombstones displays the software bin and the hardware bin. Down here it shows you the total parts tested, how many passed, how many failed, and the yield. The final test display also includes a yield per site above each of the tombstones and a header with the lot ID and optionally other parameters which you can set up in a config file. If you'd like to have a detailed bin summary, you can select the bin summary tab, and all software and hardware bins are displayed here with the software bin number, software bin description, whether it was a good or bad bin, and the hardware bin number and its description if available. It also gives you a count and a yield for each of those bins. Just like the wafer map display, the final test display has lot variable tab available. In here you can see the device name and path, the lot ID, operator ID, and any other variables that were set as application model variables. Also, like the wafer map display, the bin summary has a software bin bar chart, which gives you a histogram for each of these software bins, how many devices have fell into that bin. You can see this is being updated live. The final test display also offers a rolling yield per site. Each of these bars here from this point to here represents 50 devices, and it gives you a yield per site. If we increase the size of this, you can see more clearly the differences between sites. So if you had a site that was operating at a much lower yield, you'd see that line would be below the other lines. In this particular case, we're fairly consistent. The yield is similar between the 4 sites. If we pause operation using the Smart Test Pause, we can look at the current plunge results, and we can also look at a previous plunge results. So if you're testing large numbers of sites and you want to see the current plunge or the previous plunge, you can stop the operation of Smart Test and look at either of those plunges. The final test display also has the ability, like the wafer map, to save a chart or the bin histogram, and it also has the ability to export the bin summary to CSV file and the lot variables to CSV file. So this is very convenient for creating reports after you've run your lot. Here's our final test display again, but this time I've added the options of displaying the top failing software bins for each of the sites. So each one of these shows you the software bin number, the name, the count, and the percentage. I also have added the option of displaying, in addition to the lot ID, the device name. You could put anything up here. You could put, for example, the test program name or the operator ID or the start time. The final test display is very good at doing multi-site. In this case, we're showing 16 sites. One of the powerful features of the display is that you can control the layout of the sites. In this case, we're showing 2 rows of 8, but you could, for example, show 3 rows of 4 or 4 rows of 3. And one of the things that we've done with this with customers is we lay out the display so that it matches the plunger layout on the handler. Here we see the final test display showing 64 sites. The final test display really excels at displaying large number of sites. You can actually scale the window, and it rescales each of the tombstones to smaller, so you can fit a large number of sites into a small space on your screen, which is a really nice feature. And you can still see the software bin display on each one of the tombstones. And here we have the total count, the pass count, and the fail count, and then the yield. This display can be customized so that you can lay this out to match, for example, a carrier for a package carrier type handler. Both the wafer map and the final test displays are written in Python, which is a really easy language to learn if you don't know it already. It's very powerful and it's very easy to come up to speed on it. That enables you to customize these displays. The source code is available for these, so you can add any tabs you might want to do with additional reports or change the way the die or tombstones are displayed. You could change, for example, the information displayed down here. There's all kinds of ideas that you could use to create a display that would fit your particular needs.